Okay, next up, Fabio Labella. It's an RDF presentation. I'm looking forward to it. The paper was written by Fabio himself, as well as Henry Thompson from the University of Edinburgh.
Yes.
Yes, so please take it away.
All right, thank you. So hi everyone, I'm Fabio. I'm a software engineer at NCR Corporation, but this work has been done at the University of Edinburgh as part of my master's dissertation with Henry Thompson, which I think some of you may know. So let's get straight into it. What's rendering for RDF? It's a very simple concept really. It's just you take RDF and you transform it into HTML, which is, if you look at what RDF is, this is a pretty important thing because, the nature of RDF is to be machine readable, which means that if you want to have human readable content, you somehow struggle. You need, for example, to maintain two different versions of your data, one for humans, one for machines. It's not very good. Also, in designing a rendering language for RDF, I was mainly looking at the graph-based view of RDF, which lends itself well to like a path-based language, as XSLT does with XML. However, there is a fundamental difficulty, which is that the graph-based model is just an object syntax where, and instead that the actual serialization format changes dramatically. It can be XML, it can be Turtle, and even within XML, you have many different variations, and we're going to see why that must be the case. So as an example, it's a very simple graph. I left out the predicate names, but it can be, nose, for example. You have this one, and you don't want to be concerned with the actual serialization because this is very easy to reason about, and you want to get to this. But what's standing in your way is this. So you have turtle and you have three, if you look at the XML in B, C, and D, it's completely different. The goals I had were several. First of all, it needs to be, since you have different syntaxes, what you do at the moment, you need to use an RDF-aware processor like Gina to parse the content and then write custom code to render it in HTML. That's not good. So you want it to be declarative. You want to declare a style sheet and just use that to transform your data. You don't want to write code for each transformation. Also, you don't want to care about the syntax. I think RDF is pretty cool. RDF XML is pretty complex. I much rather reason with RDF and not with the, actually not even RDF XML, but with any serialization. I want to think in terms of the graph. And since I want to think in terms of the graph, I think it's easier if you do that with a path-based, query language instead of pattern matching, at least for rendering. So what I achieved, I hope, is this enhanced XSLT processor that allows you to write what will look like a normal XSLT style sheet, but they will work with RDF regardless of the input format. And more importantly, you can write them with the abstract syntax in mind. And the technique I use, the concept that I use is called just-in-time reflection. You're going to see what that means. So first you think, okay, you got RDF. RDF XML is a very popular serialization format, so why can't I just use XSLT on it? Then you try and do that, and you run into problems. So first of all, you're already limiting yourself to RDF XML. You can't use Turtle, and I know many people write their RDF in Turtle because it's way easier. But even if you are willing to take that limitation, it's still quite hard to write a style sheet that will work with the many different variations on RDF XML. And as it turns out, it's not a problem with RDF XML itself. It's not like, okay, RDF XML is hard, let's write a better one and a new standard that will be all right. The problem is that there's a fundamental mismatch between the tree-based model of XSLT and XPath and the graph model of RDF. So first of all, trees are rooted, which means you have one specific point to start querying your data. Graphs are not. So which one do you choose, and how do you serialize that? They are connected. Instead, in RDF, you can have two statements in the same graph. They are completely disconnected. And perhaps more importantly, they are acyclic. This is a very important point. When you introduce cycles in a graph, you make very hard to fit that into a tree. And they're also re-entered, which basically means that a node can have more than one parent. And you can picture that as the typical diamond inheritance problem in object-oriented programming. So you have this node that's the nephew, like grandson of one node in multiple ways along multiple paths. So what does that mean? When you try to serialize the RDF graph in a tree, so in XML, some edges can be represented using the structure of XML, right, like nesting. Some other edges can't. So if you have a cycle, you can't just keep nesting. So how do you decide which edges do you want to encode with structure and which ones you don't? Well, there's no uniform way to do it, and that's why you're bound to have syntactic variability in RDF XML, which in turn makes very hard to write a style sheet that will work in the general case. So let's talk about reflection. So what's a reflection? Reflection basically means you have your data in different formats. You somehow abstract and you get to the abstract model of your data, and then you reserialize that model in the same format you started with, which sounds very hard, but an example perhaps clarify it. So you have this statement. It's just Alice is a person. It's Turtle, RDF abbreviated, and RDF XML. These are all very different, but they all encode the same information, right? Which is this very simple thing. So this is the second step of the reflection, like when you abstract your data model. And then you reserialize that again. For example, I use that format. So as it turns out, this already helps you quite a lot, because you can unify all these different formats in a unique normal form. But that only solves one half of the problem. Because basically what you do, you reflect your data and you have your XSLT processor work on the reflection that's fed into it with an extension function. So XSLT is syntax unaware, so all you need to do is design a normal form that will work, that will be easy to query, and you're done. But as I said, there's a fundamental mismatch, so it's still very hard to do that. But to overcome this limitation, you can use just-in-time reflection. So what's that? So just-in-time reflection is, first of all, an in-memory representation. So you don't actually need to write a new XML file with your reflection. It's in memory. Second is, of course, it has to be processable by XSLT. And what that means is that in memory, you use the same structure that's used by your XSLT processor after parsing. So when your XSLT processor executes it, it doesn't see any difference between your reflection and a normal XML file. But more importantly, it's generated on the fly. So you don't serialize your data and then use XSLT on the reflection. This new processor analyzes the query step by step and produces the reflection as it goes. And as it turns out, this is quite important, because let's take, for example, this cyclic graph. Alice knows Bob, Bob knows Alice. So I said before, you can't serialize that in XML. Well, that's not exactly true. You can, but you're going to have an infinitely deep tree, because you keep nesting. So, that seems impossible, but if you use just-in-time reflection, that's not a problem at all. So what you have here, this call to reflect will give you access to the reflection, and then you say, okay, each child of this function is a subject in the RDF graph, and then you just query for its child and the person that Alice knows. And this works with Bob as well. If you put Bob here, it will give you Alice. So what it does, it basically lets you write your style sheet as if you can have this infinitely deep tree, serialized, but you don't actually need to serialize, and that's why it works. So you might see that's a bit of like clutter around here, boilerplate. The reason for that is that in XSLT 2.0 you can't start a match expression with a function call. As far as I know, this might go away with XSLT 3, so you might be able to write this, which looks a lot better. With just-in-time reflection, you don't have to worry about having infinitely deep trees, which in turn enables you to, to design a very easy to query normal form. But there are a few caveats. First of all, if you use the descendant axis and you have a cycle, it will not terminate. Because if you think about it, if you try to reflect on the descendant axis, you're trying to reflect the same structure infinitely often. So it's basically like serializing it. That's what serialization does. You have a query that takes, walks the whole document. Also, the descendant axis, in case of a reentrant graph, will cause your node set to have duplicate nodes. Because you have this node, yes, two parents, and this diamond thing, and the descendant axis will get there in two ways. So you will have the same node twice. However, this can be easily solved by transforming the implementation of the descendant axis to use graph depth first search. It's actually a very old problem. All you need to ensure is that you never visit the same node twice, which will ensure that your search always terminates and that you won't have any duplicate nodes in your node set. So, having said that, let's have a look at some highlights of the normal form that I chose to implement. So it's very important to notice that this approach is not tied to the normal form. I chose this one because it seemed a good compromise between usability and conciseness, but you can have a new reflection generator which implements a new normal form. And the details are in the paper, so you're just going to have a few highlights of how the normal form looks like. So each XML node wraps an RDF resource, which seems a reasonable thing. The first difference is that, of course, you can start reflecting from multiple routes, because the RDF graph is non-rooted, so you don't have a standard concept of a route. And the way it works, basically, you say reflect, and reflect will have several children, and a children for each subject in your graph. So you can look at your graph and I want to start from this and reflect from there. And the basic format of your path expression will be this one, which is very intuitive in my opinion. You got just as you will walk on the graph, you have subject, predicate, object, and so on. There are a few gotchas when you write style sheets in this way. So first of all, as I said, the descendant axis is a graph-based search, whereas normally XSLT processor implements the descendant axis as a tree depth first search, and that's a fundamental difference. They don't handle cycles. This algorithm does handle cycles. The parent axis is another bit tricky issue. Obviously, you can't get around the fact that in the XPath model, a node can have only one parent. So what happens when you have two? Well, the way I solved this problem is your parent axis query just backtracks. So if you start reflecting from here, you get here, and then you say parent, it will go here, because that's when you start reflecting from. If you start reflecting from here, and you go here, and then you call the parent axis, it will go back here. I couldn't see a better solution than this one, unless you change the X1 model and the implementation completely, and you allow multiple nodes for the parent axis. I think this is a good compromise for most cases, because remember, if you want to get here, you can just start reflecting from here in the first place. So it shouldn't be too much of a problem. But if you have a better idea on how to solve that, please let me know. Let's walk through an example that I actually generated with my processor. You have the graph that we have seen at first, a very simple graph, but notice that it has a high degree of circularity. So if you don't handle that, your search will never terminate. And the processor does not care about the format in which the graph is serialized. So in this case, I use Turtle because it's easy to read. And so I went on to write a style sheet for it. Just a few, I have fragments, obviously. So a call to reflect will give you access to the document, basically. And you can look at it as, you have this infinitely deep tree, and it's somewhat similar to, lazy evaluation. You have this tree, it's there, you don't care, and then once you actually query, it will, realize it, basically. So you say for each child of the node, which translates into for each subject in your RDF set of statement, do more stuff, and then you select all the descendants whose parent is a FOF node. Because remember, when you create a descendant access, it will give you both predicates and objects. These are all encoded as elements in my normal form. And then you just get the name, and the result is this one. So I was able to write a style sheet without having any knowledge of RDF XML at all, which I think it's a nice thing to have. So I skipped over a lot of more technical details, but I think I was quite quick. So if you have questions.
I noticed the last part when you move on the descendant axis. So back. No,
the code. Oh yeah, sure. Sorry. Yeah.
Isn't that a problem? I mean, with the infinite structure that you have, you may rely on the processor not to try to expand the entire subtree. Because if you have, an infinite structure.
They will handle that, because the way I implemented it is it doesn't use a normal XLT processor.
Oh.
It's
So you control the
yes. Like I use Saxon, and Saxon has this interface called node info, which, and basically what you can do, it's a bit tricky, but you can do it. You can re-implement it and have a mapping into a completely different data model. And this has already been done. You can have DOM and JDOM. Mine is a bit more ambitious because it maps to a completely different thing, but you can do it. And the descendant axis, you need to change the behavior, obviously, because you're in a graph here, so you need to keep track of cycles. And when it gets to a node that is already visited, it stops exploring that branch. So you won't, and that's why I chose this graph, because it's a high degree of circularity. So if my implementation wasn't right, then it will just blow up. But it works, apparently. Yeah, sure.
Yeah, follow on that question. Have you thought about, you're saying you need your processor, your doctored up processor, plus the reflect function, all that I'm saying?
Yes.
To work. So what, as an entry point, have you considered using a mode to sort of indicate that processing?
Yes, I've thought about different ways to do it. One thing I liked about extension function is that, at first we wanted to implement several normal forms and sort of match and compare. but since it was done for my dissertation, we had a very short and most importantly non-extensible time frame to do it. So we settled with one, but I wanted to keep extension functions so for example, in my normal form, statements whose object is a literal are encoded via attributes, which it's good for conciseness. But you cannot have two statements with the same object and different literals, because of course you can't have two attributes with the same name. But you still want to have conciseness in every other case, right? So if you have a extension function, you can actually say reflect with this normal form, and then call another extension function to give you access to another reflection. So you can choose, you can use the concise one when you need it, and then switch to another one. If the concise one won't do. I still have to implement it, but I leave it there because it's a good point of exploration. As I said, I wasn't too fixed on my specific normal form, because a lot of people might have different ideas on which one is the best one. So I wanted to keep my yeah, sure.
Your XSLT was using 4 each loops.
Yes.
Could you do the same thing with apply template recursion, or would that end up going down right hours?
I think I did it, and it didn't blow up. But in terms of my implementation, as I said, it's more of a proof of concept. It's not production ready because I had to, do it for a dissertation. I am working on it, and I'm going to be made to, public it into GitHub. And I remember doing it with apply templates, and it did work, because basically all you see is node info and the methods in there. So once you implemented those, you should be all right. And but I'll look more into it and sure.
I wonder if you experience any problem when processing a blank node in RDF.
There's no problem actually. I was expecting problems. Somehow it works very well, because I used an RDF engine to sort of query data, and blank nodes have these identifiers. So the only problem is that you need to know the identifier, the local identifier. But with XSLT, you can just use a wildcard match. So you really have a very nice syntax for free, because instead of saying someone, you just use a wildcard match, and it will do. I didn't expect it to work that smoothly, but you get nice syntax for blank nodes for free, basically. So yeah. Yeah, sure.
Yeah, you were talking about having descending and ascending.
Yes.
Axis, but if you ignore the direction of the relationship,
Yes.
the inverse.
Yes. Yes.
So could you use that to?
That's what you should do. But what I'm saying is, if you try and do back and forth, since the parent axis has a different semantics, you might incur into strange behavior. That doesn't mean that you should use that. You shouldn't, but it's a limitation. I thought it was fair to point it out. And also, if you try, for example, it's a more subtle one, which is related. If you use the descendant axis and then the ancestor, some nodes might not be there, because since you have depth first search, you will visit each node only once, and then when you go back up, you might not have gotten there, because you might have been there twice. So what happens? It's very hard. I should have put a picture in there, because it's very hard to explain in words, but it's very subtle. And as you said, you can just think of start from a different route and descend, and you'll be fine. But you can, if you're interested, that I put that in the paper, and there's a nice picture there. It's much clearer than I'm sounding right now. So yeah.
Okay, thank you, Fabio.
Thank you.